We always hear about forests being like these giant carbon sponges, right?
Right.
Soaking up CO2, crucial for fighting climate change.
Yeah.
And that's true, of course, but what if I told you that a brand new study has kind of flipped the script on where most of that extra carbon on land actually ends up?
Yeah, that's the really fascinating thing about this research.
Okay.
You know, we all know that terrestrial carbon sinks, those land ecosystems that absorb more carbon than they release,
Right.
are super important. You know, they offset something like 30% of the emissions that we create.
Huge. Yeah.
But the real, detail,
Nuance.
the nuance,
That's
the part that we're going to, dive into today is where exactly that captured carbon is going.
Exactly. And you've shared some really compelling research with me that looks into that.
Yeah.
And I was pretty surprised by some of the findings, I got to say.
Yeah.
So our mission today is to unpack these insights
Okay.
and understand this new perspective
Yeah.
on our planet's, carbon balance. Let's do it.
Let's jump in. So, for the longest time, the kind of dominant view has been that forests are the primary terrestrial carbon sinks.
Right. Makes sense.
It's intuitive. You see vast amounts of living biomass, and they are very important.
Yeah. It's the story we've all heard, right?
Mm.
Like trees inhale CO2, store that carbon, exhale the oxygen.
Yeah.
Pretty straightforward.
Simple.
But
this research...
so it's a curveball.
If there was a curveball, yeah. So between 1992 and 2019, terrestrial carbon sinks actually grew by a significant 30%,
Okay.
which is a huge amount of carbon being stored.
That's a lot.
It is.
Yeah.
And here's the picker. Only a tiny fraction of that 30% increase, something like 6%, is attributed to vegetation, mainly forests.
Well-
So think about that. The vast majority is not going into trees.
So that's like a real aha moment.
It is an aha moment.
If it's not going there, then where is it going?
So the answer to that lies in what we call non-living carbon pools. And these are reservoirs of carbon that are essentially dead organic material. So, decaying plant and animal matter, the organic components of soils, sediments at the bottom of lakes and rivers, and even wetlands.
Okay, so all the organic stuff that's not alive and growing anymore.
Precisely. And what the research shows is that these non-living pools are where the vast majority of that 30% increase in carbon storage has been occurring.
Okay.
So we've probably been really underestimating the role of this dead organic matter in locking away carbon.
That's really interesting. It is interesting, right? Because we hear so much about planting trees, which is still really important.
Absolutely.
But this kind of highlights another dimension to this whole carbon storage conversation.
It does.
Now, you mentioned that it's really tricky for researchers to measure the changes in these non-living pools.
Yeah.
What makes it so challenging?
It's a great point because it's very different to, for example, measuring a forest's biomass,
Right.
which you can do using satellites. You can do ground surveys. Assessing changes in something like soil carbon or deep underwater sediments requires a lot of quite complicated methods. So it often involves physically taking samples,
Okay.
taking them back to a lab, doing analysis, and this needs to be done over really long periods.
Right.
And the sheer variety and scale of these non-living pools just makes it a really significant scientific hurdle.
Right. You can't just, point a sensor at a swamp
Exactly.
and get a carbon reading
You can.
like you can with a forest canopy.
Exactly.
So the fact that they have quantified this is a big deal.
It is a big deal.
Now, something else that really stood out to me in this research was the kind of unexpected role of human activities in boosting carbon storage
Right.
in these non-living pools. How does that work?
So I think if we zoom out for a second and think about the big picture, we often think about human actions as primarily driving carbon emissions. And that's absolutely true.
Yeah.
But this research highlights some of the ways that we actually inadvertently contribute to carbon storage.
Interesting.
So, for example, when we build dams and artificial ponds,
Okay.
these actually create environments at the bottom of those structures that are really depleted of oxygen.
Right.
And that lack of oxygen really slows down the decomposition of organic matter that falls down there.
Okay.
And that leads to a more permanent burial of carbon.
So these structures that are built for things like water supply or generating power
Yeah,
are kind of accidentally helping to trap carbon.
that's right.
That's pretty cool.
It is.
What else?
So another interesting one is the use of timber.
Okay.
So when we harvest trees and then use that wood for building or furniture,
Yeah.
the carbon that's stored in that wood is effectively taken out of that rapid carbon cycle.
Okay.
And it's stored for a much longer time.
That's a good point. We always hear about deforestation, right?
Mm-hmm.
And releasing all that carbon.
Yeah.
But the use of that wood is actually like a carbon sink.
Exactly. And this actually leads on to another really crucial finding, which is that the researchers suggest that carbon stored in these non-living pools tends to be more durable than the carbon that we find in living vegetation.
Interesting.
So while forests are really vital, they are also vulnerable to things like fires, diseases, deforestation, which can quickly release that carbon back into the atmosphere.
Right, like we've seen these massive wildfires that just turn forests that were sucking up carbon into massive carbon emitters.
Yeah.
Like in a matter of days.
Yeah.
So are you saying that like these underwater sediments and these, timber structures are more stable long term?
Potentially.
Okay.
They're not entirely immune to change.
Right.
But generally speaking, that carbon is much less susceptible to those really rapid release events that can affect forests.
I see.
So it really gets us thinking about, how we evaluate the long-term security of where that carbon is stored.
That's fascinating. Now, speaking of forests, the research also touches on their increasing vulnerability.
Mm-hmm.
Can you explain why, even though they're still super important, why they might be less reliable as a carbon sink moving forward?
Yeah, so as we've kind of touched on already, forests are facing growing threats from climate change itself.
Okay.
So more frequent and intense wildfires are a major concern.
Yeah.
And obviously those release a lot of stored carbon. Deforestation, for agriculture and urban development is also shrinking those forest areas and reducing their capacity to absorb carbon.
Of course.
And then, there's other things like shifts in temperature and rainfall patterns can stress forests, making them more vulnerable to things like diseases and insect infestations.
Yeah.
And that can affect their health.
Reduce their ability to,
Exactly.
absorb carbon.
And in fact, the study even suggests that in certain scenarios, forests could release almost as much carbon as they're absorbing.
That's a scary thought. So the picture of forests being these like steadfast carbon guardians is really being challenged here.
Yeah, it's definitely more nuanced than that.
This must have pretty significant implications for like how we model future climate scenarios, right?
Yeah, absolutely.
How so?
Well, because we have had this limited data on carbon accumulation in these non-living pools, current climate models have probably overemphasized the role of forests as the primary terrestrial carbon sink. And, these models, they rely on accurately representing carbon flows and storage in different parts of the Earth's system to make those projections about the future of climate change.
Right.
So if a major component like non-living carbon accumulation isn't fully accounted for, then the predictions are probably a bit off.
So our climate models might be a bit skewed.
Potentially.
When it comes to, factoring in all this land-based carbon absorption.
Yeah. And this research provides some really valuable data that can be used to refine those models and potentially lead to much more accurate projections.
I see.
And particularly, it highlights processes like the burial of organic carbon in those low oxygen environments, like the bottoms of lakes and ponds, as being crucial mechanisms that are not really represented properly in a lot of the current models.
This really shows that it's so important to get a complete picture, right?
Yeah.
Of the whole carbon cycle, even the stuff that's not so obvious.
Absolutely.
Now, to kind of put some numbers on this, does the research give us some specific data points?
Yeah. So the team calculated that something like 35 gigatons of carbon were sequestered on the Earth's surface between 1992 and 2019.
Well, that's a lot.
That's a lot. A gigaton is equivalent to something like the weight of 10,000 aircraft carriers.
Goodness me, 35 gigatons.
Yeah.
That's a lot of carbon.
It is.
And has the rate changed?
Yeah. So the rate at which that carbon is being stored has actually been accelerating.
Okay.
So over the last decade of the study, annual carbon sequestration increased from 0.5 gigatons per year.
Right. So 1.7 gigatons per year.
Wow. That's a significant increase.
It is.
So this is really important research. It was coordinated by Yunan Baron from the California Institute of Technology. And their findings were published in the journal Science on March 20th, 2025. For anyone who wants to dig a little deeper, the DOI is 10.1126 science.adk1637. So I think to wrap this up, our understanding of where terrestrial carbon is mainly stored has really changed, hasn't it?
Yeah.
Thanks to this research. It's not just about forests.
No.
These often overlooked non-living pools are playing a much bigger and potentially more stable role than we thought.
Absolutely. That's the key takeaway here, that our traditional focus on forests as the primary solution for land-based carbon capture needs to be broader
Yeah.
and include these other vital carbon reservoirs. So as you think about all this, I want you to consider this. How might this new understanding of carbon sinks, particularly the role of non-living pools and even the contribution of human-engineered environments, like we talked about, how might it change our strategies for tackling climate change? Could it open up new areas for research and even, innovative approaches to carbon capture and storage that we haven't even thought about yet? It really does offer a new way of looking at how our planet's carbon cycle works and the importance of looking beyond the obvious.
It does.
Thanks for joining me.
Thanks for having me.